In this work, we consider the problem of detecting and locating unknown gas sources using a multi-agent system equipped with gas sensors. To this end, we develop a cooperative strategy aiming at detection and localization of the unknown gas sources. To validate our exploration strategy, we carried out a small experiment in a gravel pit close to our DLR site in Munich. As the first step, a surveillance of the exploration area was performed using a flyover with a drone. This permits a precise 3D reconstruction of the environment. This reconstruction allows computing 2D maps of traversable areas for collision-free navigation of ground-based robots making gas measurements. In the experiment, a fleet of 6 robots was used. To implement navigation, coordination, and cooperative data processing, a communication system is required. In our work, we consider scenarios when external navigational infrastructure such as GPS or classical terrestrial communication system is unavailable. As a solution, we developed and tested an ad hoc joint communication and radio localization system for multi-robot systems. By measuring round-trip delays of the radio signal used for communication, robots are able to estimate the distance to its neighbors. The cooperative processing of this information permits a relative localization of each member of the swarm. To this end, a distributed particle filter algorithm is used. To test the exploration performance in the experiments, we simulated the gas sources, gas dispersion, and wind using numerical tools. As it can be seen, 2 gas sources were placed in the exploration area. The wind direction is indicated with blue arrows. The gas concentration measurements performed by robots are likewise done numerically. The synthesized gas concentration is shown as an overlay color map. The robots are able to navigate autonomously in the navigation area, based on the cooperative localization strategy that uses a distributed particle filter. Here, the estimated positions of the robots are marked as red diamonds. The proposed exploration strategy relies on a physical model of the gas dispersion phenomenon, which is numerically represented using a partial differential equation. Using probabilistic representation of the partial differential equation, uncertainties of the variables involved in the model can be computed. These uncertainties determine areas of high information gain, a so-called uncertainty map. Locations with high uncertainty, marked as red, attract the robots. At the beginning, these areas are located in the downwind region of the exploration area, in the left part of the field. After exploring the area shortly, and after collecting a certain number of measurements, more accurate hypotheses about source locations emerge, and the robots are finally able to correctly estimate the source distribution. As we see here, the robots are able to successfully identify 2 gas sources at correct locations.